Hello. This demo is aimed at application developers using the Eduction SDK. It's for those of you who are already familiar with basics. We have other, more introductory videos and documentation available if you're new to the Eduction SDK, and I'll refer to these at the end. I'll discuss two features, the first of which is improved timeout precision. This allows developers better timeout control. I'll demonstrate this and give an example of how timeouts can be handled as an application developer using the Eduction SDK. I'll be using .NET on Windows in this demonstration, but Java and C interfaces are also available in the SDK, and other target platforms are available. Here, I'm working from the Eduction from Config sample program available in the SDK package. So under Samples, Eduction from Config, and looking at the .NET program. Essentially, the program takes text input through this argument, a license key, a config path, which specifies how the engine will be set up and which grammars we will use for matching, and an output file to dump the output to. To use timeouts, we have to specify a session start time. We get the current time, convert it to epoch milliseconds, and use it in the set start time precise function. This supersedes idle 12.7's set start time function, which didn't take a millisecond argument. Now that the session start time is set, we can use timeouts in the program. We can check whether the last match timed out using the last match timed out function. Here, we're using it to print a warning and break out of the matching loop that we're in. However, we also have to consider the case that there are no matches, in which case we can also check for a timeout. One way of setting the timeouts is through the config file. Here, we've set a request timeout of 1.5 seconds and a match timeout of 0.2 seconds. The millisecond precision is new to idle 12.8. As a reminder, request timeouts measure from the start of the session until the current time, whereas match timeouts measure from the start of the match until the current time. Another way of setting the timeout values is in the program on the session itself. For example, we can use set request timeout precise, giving 500 milliseconds as the argument, and that will override any config setting and set the request timeout. All right, let's see the program run. I'm using .NET version 5.0, and we build it with .NET Publish, specifying the platform identifier for Windows here. Just run the executable, then we'll see that it requires config, input, license, and output, as I talked about earlier. So let's give it our config. Input consisting of 1 million lines, so they would run for a long time if we didn't specify timeout. And a license and output. You can see that the request times out after 500 milliseconds because we specified the session set request timeout, overriding the config setting of 1.5 seconds. The second feature I'll present is table extraction. In idle 12.8, we can now use API functions to pass structured data for matching, which makes parsing files such as CSVs much easier. Turning back to the demo, we'll look at the table extraction sample code for the .NET interface. So we're in the samples and table extraction .NET sample program. The arguments are very similar to the Eduction from Config program, but we also have this flag which tells us whether or not we're expecting structured data. The config is a little different too, in that while it specifies a grammar still, we also have entities specified for each header row and each column. The grammar shows us what we're expecting for each header. For example, we're expecting a name, number, and location. And for this simple grammar, we only have 3 values of name and simple numbers and 3 values of location. Our input file is a simple CSV with name, number, and location headers and 3 simple rows of data. To parse this structured data, we define this function parseTable in the sample code. This function lets us add structured text to the session using the new idle 12.8 functions addTableCell and endTableRow. Text offset is a simple struct that holds a bytes and character offset count. For each line in the input, we split the line into cells by using the comma delimitation, and then add the contents of each cell into the session with the specified offset. Finally, we update the offset according to the length of the input. When we're done with this row, we tell the session that, and then when we're done with all the rows, we tell the session that also. Let's see it run. As before, we use the .NET publish command. We run the command using the similar arguments the last time, giving it a config, input, license, output, and this time specifying the flag, saying we're giving it structured input. See the results. See that we've identified the headers from our grammar and matched some of the data in the cells, but skipping over the pi, which wasn't in our grammar. For general information and to get started, see the Microfocus idle documentation. For more information on the .NET API specifically, see the API reference file, which is included in the Eduction SDK package.